Dog hot, diggity dog. Say another Threat Thursday live. Thanks for joining us, everybody. I'm Trey.
I'm Jared,
And
and
I'm on
Tyler's
mute, but
muted.
I'm Tyler.
Yep, and there's Tyler. So thanks for joining us. We're going to talk about something a little different today. Usually we'll do like a bigger breakdown of a threat actor, maybe some of the cool stuff they're doing lately. But we're going to make this into a little smaller, kind of bite-sized piece where we're going to talk specifically about a ransomware variant. Jared, you want to kind of give them a little intro and idea of what we're looking at?
Yeah. So recently, especially in 2025, the ransomware as a service group, Qilin, has grown massively. They're a Russian-based ransomware as a service group where basically you can contract them and get access to a dashboard and use ransomware like it's SaaS. They have usually targeted manufacturing, healthcare, government. Notably, I think it was an NHS, National Health Service attack that was like massive sometime last year. And they initially started with a Golang based agenda ransomware, is what it was called. But from 2024 onwards, they have added a few new things, and especially they have converted it into Rust, which is very interesting because it runs faster and it's memory protected. It's a very interesting language for malware, and it's something that is kind of interesting to have to reverse engineer in a world where Rust is kind of growing as this language that threat actors use. Excuse me. So what we're going to do is go over the ransomware itself, kind of how it works, and then we are also going to go over how we built our own emulation for it that we use for our Purple Team engagements and things like that, and kind of how we also do so more safely than just launching ransomware and pointing it at an entire system's C drive.
And it's wild that in 2026 we have to say that, but
Yeah.
some vendors out there we won't disclose. That's one of their key rules for testing ransomware is they want you to run ransomware. That is a terrible idea. People don't do it.
Yeah. Do not run a live sample. It will be bad.
But with that, this one's a pretty cool Rust variant that Jared's going to walk you guys through. So let's dive in.
Yeah, so what I'm going to do is I'm going to kind of go over a flow chart of ours, and I'll also point out the differences and where Qilin would be doing something maybe more destructive or different than we are. I will point that out. Let me get my share going here. All right, so there's a few ways that they usually get execution. One of them, obviously, that's pretty common nowadays is DLL sideloading. For this one, we just use a run DLL32 command to load this binary. So what we did is we packed a Rust binary into a DLL, and that DLL is loaded through run DLL32. This is a common way for ransomware execution. Another one Qilin does a lot is bring your own vulnerable driver, which can kill EDR, and then they can just invoke it like that as well.
And as far as execution goes, Jared, they're typically in something like you're showing here in C users or temp. Yep. They tend to hide in those spaces, and they typically mostly target Windows. And here recently, they've been seen targeting virtualization infrastructure.
Yep, they can target ESXi now as well, which is very, very fun. So right away, this brings us to the first guardrail that we set. We are not going to throw it at the entire C drive. That's irresponsible and can cause a lot of issues on a testing machine. So we are going to limit it to C users. That's going to be the first guardrail. That's where we start to differ. But what it does from there is it loads an RSA 4096 public key, and then it generates a victim ID with Qilin, the host name, the username, and then just some random data afterwards. And then again, if it didn't find C users, obviously it will find C users, it would exit. This is just kind of that guardrail where if it can't find what it needs to do, it will exit and not encrypt anything. So from there, it is going to begin terminating a bunch of processes and services. It will try to stop everything that it can that's related to recovery, logging, monitoring EDR, it's going to try to kill as many of those as it can, so that it can run unfettered throughout the system and then further the network. So it does just a quick sleep to allow all of that to finish. And then this is something that is also a good detection metric, because almost all ransomware nowadays deletes shadow copies. So it does VSS admin, it runs delete shadows and deletes every shadow copy. It also uses WMIC and PowerShell, and then it uses BCD edit to disable recovery as well, leaving the system in a state that you have to either give in to them, or hopefully give in to them or recover it another way. From there, yeah, go ahead, Trey.
Sorry to interrupt you here, Jared. This is a really interesting behavior, and it's kind of popped up the question for me, because we've done, dozens and dozens of engagements with organizations and all the different market verticals at this point. And I don't remember the last time I actually saw someone in present day using shadow copies. So I'm wondering why this behavior kind of still sticks around, right?
Yeah.
It's curious.
It is curious, and it has become a point of of detection platforms also using this as one of their kind of biggest indicators of ransomware, where you can also sometimes see that if VSS is not manipulated in any way, it may pass on to further steps. From here, though, it actually begins the encryption flow. So it's going to start walking the directory tree from C users and going through files and folders. And basically, it's going to do a few things along this side here. It will check if it's a file. It will check if it's already been encrypted and given that .qilin extension. And then it will check if it is the ransom note or not, because if you encrypt the ransom note, you're not going to get whatever you want, and you're gonna have a bad day as a ransomware actor. And then it just looks for the target extension list. This is there to stop it from encrypting necessary files that keep the machine running. So if it starts encrypting certain things that aren't loaded, if they try to get loaded later, like a DLL, it's going to start causing issues in the system. So we also have it look for just these specific extensions, doc, PDF, SQL. It's a very long list. And then it's going to look, read the plain text file, and if it's greater than 0, it's going to start this encryption flow here. And what we've seen recently is that Qilin has adopted Cha-Cha-20 as their encryption standard of choice. So they generate a random 32-byte file key, and then it creates a cipher, generates a bunch of stuff. So it uses, just for testing, we just use the ciphertext is cipher.encrypt. And then it encrypts the file key with that RSA public key we have, with SHA-256 padding. And then what it does to make sure that later analysis can't just rebuild, it will zero out the file key from memory so that it can't be found in like forensics later, and they can't just use it to decrypt all the files. It also does some fun with the footer and sets the magic bytes to Qilin v2. After that, it just combines everything, writes the file, and then deletes the original, and goes through this loop until it's ready to drop the ransom note. From here, it will generate a ransom note with the victim ID, contact info, some threats, and then the instructions to really kind of give a user that urgency that they need to contact someone and pay this ransom, or that their data will be deleted. It also drops the ransom note in 2 spots just in case there's issues or the user doesn't find it, and then it will open it. And this flow is very, very close to the actual Qilin, the Qilin .b is what it's called. This one has a few differences. Specifically, it does not wipe Windows event logs, which Qilin.b does, just because we do need those for detection artifacts. It also doesn't do anything laterally. So Qilin usually will pack in psexec and then attempt to psexec out throughout the network and then spread like that. We kept that out of this binary so that it wouldn't spread further than it needed to. But that is everything on this. Do you guys have any input?
The other thing I wanted to highlight here that we do in our threat, but we don't do in this binary specifically, is they also pack in some different pieces and parts for privilege escalation, trying to get them. They'll take an embedded Mimikatz module itself, where they'll try to steal tokens from things like LSAS or WinLogon, and kind of embed that already in there instead of trying to bring the tool in after the fact. So I thought that was a pretty neat little piece of this as well.
Yeah, it's really interesting to see what they're doing. It's honestly it's pretty it's relatively advanced ransomware, which is one of the reasons that we're seeing it so prevalent, especially when you can just kind of procure it at this point as a service.
And it's extremely flexible. Its defense
Mhm.
rating is cool, and kind of the access capability and propagation is interesting too, because they're using not just like newer CVEs that are popping up in like the
Mhm.
Fortinet, but they're going back to some of the old like tried and true methods as well, and taking advantage of older CVEs. So they're kind of it's we're seeing it a lot more like what's old is new again is coming back full circle, where
Mhm.
it's like it's falling out of the um, definition libraries for AV and EDR. So they're retrying a lot of the old behaviors and
Mhm.
vulnerabilities, and it seems to be working.
Yeah, and it is working. But yeah, this kind of wraps up the actual talk on kind of how we emulated it. What I'll do real fast is before getting into a little bit of the secret sauce that we have for how we design these testing binaries. I did just want to pull up my machine to kind of show you what a post infection would look like. Let me swap my share over to my parallels. All right, so what you can see here is there is a ransom note that I have opened here. Let me see if I can zoom it in a little bit. So you see your network has been penetrated, threats, do not attempt to recover it yourself. And then you see I have a unique ID here, which is Qilin, host name, my username, and then just some random data. And then you can see all of the other stuff here. And in the file system, you'll see like I had a desktop.ini here previously. It has been given .qilin, and you can no longer do anything with it. There is no desktop.ini left here. And as you can see, the desktop as well, absolutely littered with useless files. So that's kind of what it would look like, just as an example.
What's kind of interesting too here is them as a
Mhm.
service model. Like
Yeah.
um, you as an affiliate get the ability, like you could customize
Mhm.
these ransom notes if you wanted to. You could customize the file extensions. They've made it to where you can almost kind of control this and how the process works.
Mhm.
It's different. It's cool.
Yeah, it's a literal dashboard that you can configure from. It really does work like SaaS. It's super interesting to see. But yeah, pivoting from there, we also do have kind of some tips on if you are developing a binary for your purple team testing. What we like to do to make sure that it doesn't run wild and do things it isn't supposed to do. So here it is. I had this whipped up. So basically, some of the main safety guardrails that we use and that we used in this one, first off, is we scoped the main directory. We've set a constant in the code that the target directory is C users. So if there's going to be a check, there's a function later on. If it does not find it, it will gracefully exit. This is something that's really good to do, just so you can limit what files are going to be touched if you're emulating ransomware. That's where the silent exit comes in on the right as well. We also made sure it does not propagate across the network. And we also made sure to save the full RSA key pair in case anything went wrong. We would be able to decrypt files, even though the ransomware itself zeroes them out. And then just a couple of additional ones that we like to add in, an execution timeout. So if it's something that might be a keylogger or something that's running continuously or like a C2 implant or some sort, setting that timeout, having a hard limit on runtime means that it won't just sit there and keep doing what it's doing. We also can implement like a host name check. It's very simple to just interact with a Windows API in the code, get the host name, and if it's not, say, the hard coded one that you compiled this binary for, it will just exit. And then the same thing, it can check the system time and system date. And if it doesn't match a specification set in the code, it will exit. These are a few things that we do to really make sure that we're not going to not only blow up our own lab, but go too far and blow up a client lab, for example.
Yeah, and I think these are a great thing to bring up here, Jared, because we are executing these with customers in test environments and sometimes in production because they want to
Hmm.
see how everything actually runs.
Yep.
We want to ensure that they get a safe but valid
Hmm.
engagement. So these are kind of some of the cool ways that we do that.
Yeah.
Uh, all in all, I think this is kind of like best case scenario and things you could look for when it comes to a safe execution and check of
Yeah.
ransomware. Like you might not be getting, the propagation detections, but catching it on disk before it has a chance is usually kind of the best case scenario anyway. And with the way you've got this built out, it gives all the typical indicators you would expect from one of these binaries and implants in general. So it's kind of covering all of our bases
Hmm.
there.
Yeah, and you can do a lot. What I also like to do is I like to add a running log file that will go somewhere, somewhere that's probably not going to be interacted with by whatever binary we're using. And that gives, not only the operator on our side, but it also gives the blue team something to just be able to grab and look at and see everything that was done, just to, validate that everything was up to spec. We didn't do anything we weren't supposed to, and that, everything was successful.
Awesome. Well, that all in all, that was a pretty cool breakdown of that Qilin ransomware variant. Is there anything else you guys want to chit chat about before we call it on this one? So I think this will be the first one we might actually be right at close to time.
Yeah, maybe. But yeah, that is everything that I had.
All right, yeah, no questions down in chat for today. Thanks for taking the time to walk us through what we got built here, Jared. This one's
Yeah.
one of the cooler ones we've done recently. So with that, we do these every 2 weeks, everybody. If you would like to come hop in, talk with us about specific threat actors, ransomware variants, you name it, anything cybersecurity and threat related, we're here for it. Just let us know. We like to talk about what you guys are interested in and what cool new things are happening. So we will be here if you guys want to talk. If not, we will see you in 2 weeks. Till then.
Yeah. Thanks for joining. See everybody.